Hello, and thank you for that introduction. I'm happy to be here to speak today at the Embedded Vision Summit. You might be aware that BASF is a chemical and materials company. Indeed, my own PhD is in polymer chemistry and catalysis, but my division, Surface Solutions, is about more than basic chemical materials. We supply coatings to many different industries, including the automotive industry. As part of that effort, we have expertise in color. We design color collections, report on color trends, supply worldwide color design support, and develop innovative color concepts. Recently, many of these innovations have related to computer vision, such as developing IR reflective dark colored base coats for LiDAR sensors. But today, I want to talk to you about how the color science underlying the chemical property of fluorescence can be used for object detection and classification. To do that, I think it is useful to take a quick look at how the most common tools for object detection and classification work. Convolutional neural networks have been wildly successful at these tasks by learning features in the convolutional layers and correlating how the presence and arrangement of those features relate to different object classes through the fully connected layers. Of course, this is a hard task because in many cases you want to be able to detect and classify a large number of items, and the images you get may have a large number of arrangement, views, and illumination conditions. Still, there's been lots of great work at improving the algorithms, the training sets, and the processors to make CNNs function well. But I don't think you disagree that it is still expensive and time consuming to put together a high quality training dataset and CNN system, and in many cases the predictions we make with these technologies are less useful when the use case requires a higher level of certainty.